Alright, so we're going to finish up this section here. Other ways to factor polynomials. Now, these, again, are going to look very similar to the ones that you already know how to do, which is great. Factoring by grouping. This is when you have four terms group the first two, group the last two, and pull out the GCS. Okay, this is going to look very, very similar to what you had before when we were factoring quadratics. We'll do an example of this. Factor when in quadratic form. This is used usually when you have a quartic trinomial. Factor like a quadratic, or you can usually use difference of squares in cases too. If all else fails and you can't factor, then your last resort, and I guarantee this won't happen for the standard, but it might happen like later on when we're graphing. But if you can't factor, you can still find your x-intercepts. This is when you graph on a calculator and use the zero feature. To find the x-intercepts. Because as we discussed already, that the answers to all of these problems are going to mean the same thing that they did when we answered, when we factored quadratics. And what it means is all your answers are the x-intercepts. Okay, because I want to make this video short, plus I don't have a whole lot of time right now, we're going to jump right into the examples. And again, because you're kind of already familiar with this, it should go a little more quickly. And we're going to factor it and solve. So let's start with, you know what, actually, since we're solving, let's do this. 0 equals x to the 4th plus 7x cubed minus 8x minus 56. Okay, whenever you have a quartic or a cubic and you have four terms, then factoring by grouping is going to be where you want to go. So we're going to group the first two, group the last two. Then just like we did with the quadratics, we're going to pull out the greatest common factor here, which is x cubed. We're left with x plus 7. We're going to pull out the greatest common factor here, which is negative 8. Left with x plus 7. And then I have x cubed minus 8. And x plus 7 is my factors. Now, the kicker here with polynomials is almost always, when you get to this point, you can usually break apart or factor one of the parentheses more, which in this case I can factor this more because this is a difference of cubes. So it's a difference of cubes, which means I'm going to factor it using this pattern. My a is going to be x, my b is going to be 2, because x is the cube root of x cubed, 2 is the cube root of 8. So we get x minus 2 times x squared plus 2x plus 4. And then I solve by setting each of my factors equal to 0. So in this case, I'm going to get 2 and negative 7 as my answers. And then this is a scenario where I have to use the quadratic formula. So I get 4 minus 16, so I get 12i all over 2. Okay, so there's two answers 2 answers. I should have 4 answers total, which I do because I have a quartic. That means it's going to cross in 4 places, or I should have 4 answers. In this case, it's only going to cross in 2 because 2 of my answers were imaginary. Okay, so I'm going to flip. Factoring when in quadratic form. Okay, we're going to make an A and a B here. And let's do this one first. 3x to the 4th plus 15x minus 72. Okay, now I know this is not, I think this was, sorry, that should be 15x squared. I know this is not a quadratic, but it kind of looks like a quadratic because you have 3 terms. And so we're going to actually be able to factor this like a quadratic. The first thing that I always want you to do is see if there's a greatest common factor. So I know 3 goes into 15, but let's see if 3 goes into 72, which, oh good, it does. So I'm going to plot a 3. And then I can either choose to factor the long way by multiplying A and C together, but because there's no number in front of x to the 4th anymore, you can shortcut your factoring because it's easy to kind of figure out in your heads, guess and check. So what times what gives me x to the 4th? Well, x squared and x squared multiplied together give me x to the 4th. And then I need 2 numbers that multiply to get negative 24 and add to get 5. If you think through your options, 12 and 2 don't work. 6 and 4 don't work. Why can't I think of them? Some of you are probably shouting at me right now. Why can't I think of it? Oh, 8 and 3. Duh. Okay. So 8 and 3, and 8 is going to have to be the positive 1, and 3 is going to have to be the negative 1. Now, if we're solving this, then at this point you're going to take each factor and set it equal to 0. In this case, I'm going to get x equals plus or minus 2 square root of 2, because at this point you're going to take the square root of both sides, and then 8 breaks up into 4 and 2. I should have an I there. Okay, so those are 2 answers. And then plus or minus the square root of 3 are my other 2 answers. But I should have 4 total because I have a quartic. Okay, and then I think the last example we're doing, I'm going to save this for doing it in class with you, probably on Wednesday. It's going to be a problem that looks like this. Okay. Now, I know I have a quartic again, but it kind of looks like it might fit the difference of squares. So let's see if it does. Well, can I take the square root of 81? Yes, I can. The square root of 81 is 9. The square root of x to the 4th is x squared. Can I take the square root of, you know what, I'm going to change that to 4. No. 16. Okay. Square root of 16 is 4. And then difference of squares pattern is a minus b times a plus b. So I have 9x squared minus 4 times 9x squared plus 4. Now, like I stated, over here, usually when you break it down to parentheses, you have to take a second look and just make sure you can't break it up any further. In this case, I can break that up further because that's also a difference of squares. So that's going to break up into 3x minus 2 times 3x plus 2. And this one I'm going to leave as is. Okay. So for what we're doing tomorrow, you're going to do lots of practice over quadratic form, over factoring by grouping, and then factoring the patterns, and then finish up your catapult project. This is Crisscross signing off.